What's the underlying technology in these sensors?
Well, it's easiest to look at that by looking at our FlexiForce sensor. Just a single point sensor. You see you have a conductive layer on the top and another conductive layer on the bottom. And then our semiconductive ink is printed in between. So as you squeeze on the conductive plates, you get a change in resistance and more current flows, and that's how you measure the force.
What kind of range is it practical to measure?
We can measure as low as about 20 gram force, and we can measure up to 1,000 pounds on this sensor right here. But we can measure much higher forces over a larger area. The sensors are limited to about 10,000 psi of pressure.
What kind of environmental factors do you have to consider when you're specifying one of the sensors?
The temperature sensitivity is 0.2% per degree Fahrenheit, or 0.2% of the sensor output change. So that is something you need to take into account when calibrating. To make sure that you build different curves for different temperatures or account for temperature somehow. Also, high humidity and moisture can be a concern. They are sealed with an adhesive around the perimeter, but if you actually put it in water, after a few hours, water will start to seep through and contaminate the sensing area.
What kind of circuitry do you need to drive a sensor?
Our typical circuit setup is a basic little op-amp circuit, which is shown right here. And it's fairly inexpensive and easy to put together. Just a couple of resistors and an op-amp, and you supply it with anywhere from 1 to 10 volts. And that gives you an analog voltage output that you can put into your DAC system or your control system.
What's the smallest practical size for a sensor like this?
We can make them down to a few millimeters across for the sensing region.
Is there anything that limits how big you can make them?
They're printed on steel mesh screens, so you're looking at about 2 feet as a limit for the length of the side. And typically, we prefer to make a smaller sensor. It's what gives you better repeatability, better cost.
What are some of the typical OEM applications?
So there's a whole variety of OEM applications. Our typical high-volume customers are medical devices, things like infusion pumps, athletics training devices, some consumer electronics applications, anywhere where you need to measure the force between two semi-solid or solid surfaces. And we can make sensors down to quantities of a few thousand per order up to millions a year.